Day 707 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3740, minimum distance between three equal elements 1. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go and check out that link in the description so you can get you some. Now let's see what the question says. You're given an integer array nums, a tuple I, j, and k of three distinct indices good if nums of I is equal to nums of j and nums of j is equal to nums of k. The distance of a good tuple is the absolute value of I minus j plus the absolute value of j minus k plus the absolute value of k minus I, where the absolute value of x denotes the absolute value of x. Return an integer denoting the minimum possible distance of a good tuple. If no good tuples exist, return -1. Alright, y'all, so that may seem a little bit confusing at first. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input nums equals an array of integers 1, 2, 1, 1, 3. Our output is 6. So let's see how they got this output from this input. Explanation says the minimum distance is achieved by the good tuples 0, 2, and 3. So let's break this down one step further, right? So we want to find indices where nums of I is equal to nums of j and nums of j is equal to nums of k, or where all three indices are equal. So in this case, we can see 1, we have a 1 here, a 1 here, and a 1 here. So we have 3 1s, they're all equal, right? 1 equals 1. So we have a 1 right here at nums of 0, we have a 1 right here at nums of 2, and we have a 1 right here at nums of 3. Boom. So now we want to get the absolute, or we want to get the distance as the absolute value between each indice. So from here, it has absolute value indices 0 minus 2, right? So 0 minus 2 is -2. That has a value, absolute value of 2. So let's just put negative, we put -2 equals 2 ABS. Boom. Then we want to do index 2 minus 3, right? That's these two indexes right here. So 2 minus 3 equals -1, which has an absolute value of 1. Boom. Then we're going to do 3 minus 0. Boom. 3 minus 0 equals 3, which equals an absolute value of 3 as well. Boom. So once we get all the absolute values, we have 2 plus 1 plus 3. That is going to equal 6, and that's how we got our output of 6, right? So just remember this 0 minus 2, that's indices 0 minus indice 2 because they're equal to each other. This 2 minus 3, that's indice 2 minus indice 3 because once again they're fall into the tuple where they're equal to each other. Then index 3 minus index 0, that's this one and this one, those are equal to each other as well. So that's why they're included in the tuple. So just in case that didn't make sense, let's take a look at example 2. So in example 2, we have our input nums, equals an array of integers 1, 1, 2, 3, 2, 1, 1. Now, this is interesting because as you can see, we have two different sets of elements where the numbers are equal. We have 3 1s and we have 3 2s. But remember, we want the minimum possible distance of a good tuple. So we're going to go with the 2 because if we went with the 1, we'd have a higher output, right? We want the minimum. So it says the minimum distance is achieved by the good tuple 2, 4, and 6. So we're going to go with the 2s. This is index 2, this is index 4, and this is index 6. Boom. So it says 2, 4, 6 is good because nums of 2 equals nums of 4, which equals nums of 6. They all equal 2. And the distance is 2 minus 4. So once again, we'll take this index 2 minus this index 4. We could write it out again. 2 minus 4, that's going to equal negative 2, which is going to equal 2 ABS. Boom. Then we're going to do index 4 minus 6. Boom. 4 minus 6, that's going to equal negative 2 again, and that's going to equal 2 absolute value. Boom, because remember, the absolute value is just how far away is it from 0. So negative 2 is 2 units away from 0. So that's where this 2 comes from. We just want to know how far away is it from 0. Boom. Then we do 6 minus 2. Boom. So that's this index 6 minus this index 2. Boom. So we're going to come 6 minus 2. That's going to equal 4. And that's still going to equal 4 in ABS because positive 4 or negative 4, they're both 4 units away from 0. Boom. So then we do 2 plus 4. That's going to give us 8. That's where this comes from. And that's how we got our output of 8. Boom. Now, just in case that didn't make sense, y'all, let's take a look at example 3. Example 3 is when we cannot form any good tuple because we don't even have enough elements to form a tuple. So in example 3, we have our input nums equals an array of integers 1. The output is negative 1. It says there are no good tuples, therefore the answer is negative 1. So once again, this input only has one element, so there's no way to create a tuple out of one element, so we could just return negative 1. And now that we understand the question, y'all, let's get into the fun part. Let's get into the fun part, the actual solution. Solution is not that difficult at all. And now the first thing we want to do is we're going to initialize the minimum distance with the largest possible integer. So we're just going to come right here, declare a variable called min distance, and we'll set that equal to n.max. Boom. Now we're going to create a dictionary to map each value to a list of its indices in the array. So we're going to declare a variable called indices, set that equal to a dictionary int :int, come outside of that. And sorry, y'all, this actually should be, this right here should be a 2D array of integers. So the key will be an integer, the value will be an array of integers. Sorry about that. So it should be int : square bracket int square bracket square bracket. Boom, and then put the parentheses outside. Now we're going to build the indices map, and for each number, we're going to store all positions where it appears. So we're going to say for, open up the parentheses, I, comma, val. Come outside of that, we're going to say nums dot enumerated. We're going to open up the parentheses, open up the brackets, and we're going to say indices, square bracket val, comma, default, square bracket. Come outside of that, and we're going to dot append, open up the parentheses, I. Sorry, y'all. So each time we see I, we are going to store it in the dictionary on this side and as a value, but each time, or sorry, y'all, each time we see I, each time we see I, we're going to store it and we're going to append it right here. So at first this value is going to be a blank array, but each time we see I, we are going to append I to this value array right here. Boom. Then we're going to come underneath that and we're going to create an array to store the candidate minimum distance. So we'll declare a variable called sum, and we're going to set that equal to an array of integers. Come outside of that and put the parentheses. Boom. Now we're going to iterate over each value and its list of indices. So we're going to say for ind IC indices, open up the brackets, and we're going to get a list of indices where this numbers appear. So we're going to say let value equal ind dot value. Boom. Now we're only going to consider values that appear at least 3 times. So we'll come underneath this and we'll say if value dot count is greater than or equal to 3, we'll open up the brackets. Sorry, y'all, should only be one set of brackets. We'll open up the brackets And we're going to check every group of 3 consecutive occurrences, and we're going to use I and I plus 2 to measure the distance across the 3 occurrences. So we're going to say for I in 0 dot dot less than, open up the parentheses, value dot count minus 2, come outside of that, open up the brackets, and the distance is defined as twice the gap between the first and third occurrence. So we're going to say let distance equal 2 times, open up the parentheses, value square bracket I plus 2, come outside of that, we're going to say minus value square bracket I. Boom. Then we're going to update the global minimum distance by coming underneath this. We're going to say min distance equals min, open up the parentheses, min distance, comma distance. Boom. Then we're going to come underneath this, and we're going to store the current minimum distance in the array by coming underneath this, and we're going to say sum dot append, open up the parentheses, min distance, y'all. Boom. And if we found any valid distances, we're going to return the smallest one. Otherwise, we're going to return -1. So we'll come all the way down here, and we're going to say return sum dot count exclamation point equals, so it does not equal 0. We're going to make sure it doesn't equal 0, question mark. If it does not equal 0, then we're going to return sum dot sorted, put the parentheses, square bracket 0. And if it does equal 0, then we're going to put colon, and if it does equal 0, then we'll return a -1. Boom, y'all. Sorry, y'all. Let's get rid of that. Boom. So let's go ahead and give this a run and make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted. Let's see, and look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.